Hello and welcome to ResearchPod. Thank you for listening and joining us today. American school students are underperforming in maths, so how can teaching be improved to enable children to learn best? To address this issue, Dr. Jonathan Brendefur and colleagues at the Developing Mathematical Thinking Institute have developed the 5 dimensions of the Developing Mathematical Thinking Framework, a professional development program for teachers and other educators. The US National Center for Education Statistics, the NCES, has reported that elementary and middle school students in the USA are underachieving in mathematics. Additionally, their overall performance is not improving over time. In comparison with national standards, recent studies have revealed that these students are neither mathematically literate nor proficient. Studies have shown that those students completing kindergarten with an inadequate understanding of basic mathematical concepts and skills go on to struggle throughout their maths education. This research indicates that teaching methodologies need to change, particularly for students at the elementary level. A central question then arises: how can teaching maths be improved to enable children to learn? Rising to this challenge, Dr. Jonathan Brendefur and his colleagues at the Developing Mathematical Thinking Institute, or DMTI, have spent years in classrooms working with teachers and students to perfect the 5 dimensions of the DMT framework. DMT is short for Developing Mathematical Thinking, and the DMT framework is a multi-year professional development program for improving maths instruction. The framework ensures that every teacher, parent, student and administrator engages in successful maths experiences. Dr. Brendefur explains how teachers must establish, in his words, equitable learning conditions that foster understanding, which he says will enable students to become better problem solvers, both inside and outside the classroom. DMTI offers maths professional development, helping teachers apply the DMT framework to develop students' mathematical thinking. This involves building on students' ideas, encouraging problem solving, and strengthening mathematical vocabulary, ultimately solidifying concepts by communicating mathematically. To improve instructional practice and student achievement, over the last decade, the DMTI team has been developing and rigorously evaluating the DMT framework. The research team has carried out longitudinal evaluative studies that demonstrate how the DMT program affords students a better understanding of mathematics, reinforced with mathematizing and progressive formalization philosophies. Mathematizing involves employing mathematical thinking and vocabulary during routine activities such as play. Through the process of progressive formalization, an initial intuitive understanding of a basic concept is acquired. Based on this, more exact formal connotations and increasingly complex theories can then be cultivated. For example, moving from manipulative cubes to bar models to symbolic notations. The DMT framework's rubric comprises a 5-dimensional approach to teaching mathematics. The researchers note, however, that these instructional practices are not mutually exclusive. So here's a run-through of each of the 5 dimensions. The first is taking students' ideas seriously. Teachers initiate this first dimension by placing students in situations that engage their prior knowledge, enabling them to solve problems and expand their intuitive ideas. This is the onset of the development of mathematical understanding, where educators should focus on processes of mathematizing and progressive formalization. Learning resources are required to provide teachers with options to differentiate groups of students and foster both their formal and informal knowledge. The second aspect encourages students to try out multiple models and strategies. Modelling is crucial in the development of mathematical thinking. As such, students need to be able to examine their chosen problem-solving method and compare it with alternative approaches to progress their understanding. The DMT framework includes carefully selected tasks that teachers can use with their students as they advance from their initial informal ideas onto more conventional mathematical models. The third component, pressing students conceptually, focuses on building connections between mathematical strategies and models, progressively formalising students' problem-solving concepts. Teachers aim to create environments that enable students to move beyond a surface-level understanding of procedures to conceptualise mathematics and establish connections between various methods and models. Focusing on the structure of mathematics is the fourth element. Here, structure refers to the rudiments of mathematics that are constant throughout the subject, regardless of the level being studied. For example, concepts of units, relationships, and equivalence. Shifting the focus to structure helps students understand and establish connections between concepts, and entrenches structural component language relating to tasks throughout each lesson. The framework's formative assessment includes examples of students articulating and critiquing both their own and other students' models. For the fifth dimension, addressing misconceptions, teachers use students' misconceptions and mistakes as tools to construct deeper levels of mathematical understanding. When a teacher focuses their practices on the 4 dimensions we've previously discussed, their attention shifts toward the informal strategies their students use for problem solving, the mathematical connections they're making, the emerging conceptual understanding, and the structure of mathematics that brings about their misconceptions. By addressing these rather than ignoring them, teachers encourage their students to amend their thinking and make sense of maths. The framework embraces misconceptions and errors that can occur, and encourages teachers to involve their students in justifying, evaluating, and inquiring into how they solve problems. So, was it effective? Dr. Brendefur and his team have carried out longitudinal evaluative studies that demonstrate the effectiveness of the DMT pedagogic framework's 5 dimensions. They observed 268 lessons to find out how teachers' knowledge relates to their teaching of mathematics in terms of their instructional practices. Analysis of the data collected over this 6-year study revealed that providing teachers with professional development focused on increasing their students' mathematical thinking also has a beneficial impact on the teacher's knowledge. It was observed that those teachers who practiced DMT in their classrooms increased their content knowledge as their instructional practices shifted towards teaching for understanding. A review of the literature revealed a lack of rigorous quantitative research examining how teacher professional development correlates to students' achievement. To measure the effectiveness of the DMT program, the team employed a cluster randomized design. DMTI provides multi-tiered levels of professional development for teachers, so the team analysed how the minimal, moderate and prominent levels affected teachers' instructional performance. They found that the achievement of those students whose teachers adopted all 5 dimensions increased the most. Furthermore, the programme positively impacted student achievement throughout the study. Finally, what was the difference between strategy versus drill learning techniques? Students' lack of multiplication fluency has been highlighted globally as a key factor that hinders mathematical performance. The researchers compared their DMT approach with traditional rehearsal and drilling practices in an experiment comparing the teaching of mathematics to grade 3, 4 and 5 students. 12 teachers and 282 students from 4 schools with a history of below-average achievement took part in the study. 2 schools formed the treatment group using the DMT strategy method, while the other 2 made up the comparison group employing the traditional drill technique. The strategy group received fluency development instruction based on the DMT framework. The drill group received basic multiplication fluency instruction using methods favouring memorization and repetition. At the beginning of the 5-week unit, students completed a pre-test made up of 30 multiplication questions. At the end of the unit, they completed the same questions in a post-test. The results demonstrated that while overall fact fluency is important, the performance of students in the strategy group increased much more than that of those in the drill group. Talking about the experience of taking part, Anne, a third-grade teacher, says, "I saw great enthusiasm, great ownership of what they were learning. I saw huge growth in their ability to reason and problem-solve." Emily, a second-grade teacher, also praised the programme, explaining that DMTI felt like that missing piece of how do you get kids to think mathematically. It really had tangible ways of the how. The researchers are building a strong foundation. Underpinned by their research into how we understand mathematics and structure mathematical ideas, the DMTI book, called Math Facts, Kids Need Them, Here's How to Teach Them, details and demonstrates the key components required for children to develop robust foundations for learning mathematics. It includes demonstration lessons and resources for teachers and other educators to use with elementary and middle school students. Offering guidance that builds on the 5 dimensions, the book opens with modelling number facts using blocks and dice to develop maths fluency, and continues through to multiplying non-integer rational numbers. So, let's sum up the key components of DMT. Exploration of mathematical concepts is promoted with the development of informal strategies while encouraging students to play with ideas. Students learn how and when to use more sophisticated models, having built a solid understanding of various models at their disposal. Students' conceptualization is strengthened together with their understanding of mathematical procedures when they contrast different models and recognize that particular methods are more efficient than others. Concentrating on mathematical structure supports connections, allowing students to gain a deeper understanding of establishing connections between the fundamental concepts, thus increasing their knowledge and overall performance. Dr. Brendefur comments that the more you know about the structure of something physically or theoretically, the more you're able to adapt in practice situations. Visual modelling enables students to understand why one strategy might work better than another. Misconceptions can be addressed and discussed during the modelling process, deepening students' levels of understanding so they can avoid such mistakes in the future. The DMTI team has demonstrated that teachers implementing the DMT approach benefit from increasing their content knowledge as they shift their focus to teaching for understanding, which increases their students' learning progressions and maths achievement. That's all for this episode. Thanks for listening and stay subscribed to ResearchPod for more of the latest science. See you again soon.